Piston pumps. A piston pump works on the principle that a reciprocating piston can draw in fluid when it retracts in a cylinder bore and discharge it when it extends. The basic question is how to mechanize a series of reciprocating pistons. There are two basic types of piston pumps. One is the axial design, having pistons that are parallel to the axis of the cylinder block. Axial pistons can be either of the bent axis configuration or of the swash plate design. The second type of piston pump is the radial design, which has pistons arranged radially in a cylinder block. Swash plate piston pump: inlet, outlet, swash plate, shoe plate, inclined at an angle theta. In this type, the cylinder block and drive shaft are located on the same center line. The pistons are connected to a shoe plate that bears against an angled swash plate. As the cylinder rotates, the pistons reciprocate because the piston shoe follow the angled surface of the swash plate. The outlet and inlet ports are located in the valve plate so that the pistons pass the inlet as they are being pulled out and pass the outlet as they are being forced back in. This type of pump can also be designed to have a variable displacement capability. Bent axis type piston pump: inlet, outlet, piston, fixed block, moving cylinder block, an offset angle theta. Figure shows an axial piston pump bent axis type that contains a cylinder block rotating with the drive shaft. However, the center line of the cylinder block is set at an offset angle relative to the center line of the drive shaft. The cylinder block contains a number of pistons arranged along a circle. The piston rods are connected to the drive shaft flange by ball and socket joints. The pistons are forced in and out of their bores as the distance between the drive shaft flange and cylinder block changes. A universal link connects the block to the drive shaft to provide alignment and positive drive. The volumetric displacement of the pump varies with the offset angle theta. No flow is produced when the cylinder block center line is parallel to the drive shaft center line. Theta can vary from 0 degree to 30 degree. Fixed displacement units are usually provided with 23 degree or 30 degree offset angles. Variable displacement units are available with a yoke and some external control to change the offset angle, such as stroking cylinder. Some designs have controls that move the yoke over the center position to reverse the direction of flow through the pump. Radial piston pump: reaction ring, cylinder block, case, reaction ring center line, cylinder block center line, outlet, pintle, and pistons. The operation and construction of a radial piston pump is illustrated in figure. This design consists of a pintle to direct fluid in and out of the cylinders, a cylinder barrel with pistons, and a rotor containing a reaction ring. The pistons remain in constant contact with the reaction ring due to centrifugal force and back pressure on the pistons. For pumping action, the reaction ring is moved eccentrically with respect to the pintle or shaft axis. As the cylinder barrel rotates, the pistons on one side travel outward. This draws in fluid as each cylinder passes the suction ports of the pintle. When a piston passes the point of maximum eccentricity, it is forced inward by the reaction ring. This forces the fluid to enter the discharge port of the pintle. In some models, the displacement can be varied by moving the reaction ring to change the piston stroke.